Welcome back. We're going to talk about a few more things we want to do to our PCBs here. We're going to want to add a copper pour. And a copper pour is actually filling all the blank space on the top of your PCB with copper. And we're going to do that for two reasons. One is the way we produce boards here on campus is a laser has to remove all the unneeded copper. And it takes a long time to remove all that copper. You look at this board, you'll see all this empty space. Right, so the laser has to work and work and work to remove that. So we can speed up our board production. The other advantage is it gives me many more points to make a net connection. And in this case, I'll use ground. And because I'm using ground, it kind of makes a nice shield. I get better noise immunity. So let's look at how we're going to do that. I have my layer selectors down here so I can tell it which layer I want to work on. Let's do the bottom layer first. I can come up here to place. And under place, you'll see I have some options. It says polygon pour, which means I'm going to pour a polygon. The polygon I'm going to make the size of our PCB. So I'll click that, and then I have some options. It asks which net do I want. I'm going to select ground. And then how do I want to fill? Well, I want a solid region because I don't want the laser to have to work so much. If you're shipping your boards out and you want to do this, you could get a hatched region if you wanted. It would do that for you. But I'm going to pick solid. I'm going to tell it OK. And now you see I have my little pointer here. I'm going to go to the corners of my board here and outline my entire board. Of course, I made this notch, so I need to follow the outline. I right clicked when I was done, and there you see it, right? I can click on top layer. There's my copper on the top. I click on the bottom layer, and look what it's done. It's filled all the voids with copper. Now, that's fine, and if I ship my board out, having a 10 mil space is fine, because you'll see that my space between traces and the pour is 10 mils. That's a default under our design rules. Here I have clearance 10 mils. If you ship your board out to a manufacturer and have it done, that'll work just fine. If we do our boards here, it's a little tougher to solder and to make sure there's no little bits of excess copper in these little tiny spaces. So we actually want to change that rule. I'm going to show you how to change the rule. Let's go to our design rules, and I'll show you how to add a rule. If I come up here to clearance and right click, I can say new rule. And here's our new rule. And I'll call this copper pour. That's our copper pour rule. And I can change it to, and this is what we require here on campus, 50 mils. Make a nice space around there. And now let's tell it how is it going to connect. I'm going to tell it a custom query, and I'm going to tell it it's got to be in the polygon, So now I'm making a rule, and the rule says the name is copper pour. I'm going to tell it if you're inside the polygon, you have to have a clearance of 50 mils, and you'll see that I put it on top. It's above this rule. So if I look at this rule, it says everything can be within 10 thousandths, but a higher priority is on top. This says 50 mils. If I put this rule to the bottom, it would be another story. And I can check the priorities here. I can change it. I can put that 50 mil to the bottom, and then the main rule, the top priority would be 10, and everything would be spaced at 10. So I'm going to leave it at 50, and I'm going to leave that rule on top. This is what you'll need to put when you make this rule, and you can refer to this video again. I'm going to tell it apply, tell it OK. Let me double click my polygon and just tell it OK, and it says it's been modified, but I'd like to re-pour. Yes, I want to re-pour it. And now look, I have a 50 mil clearance. around all this. Much better. So let's select top layer, place, polygon pour, connect it to ground. I'm going to do the same thing. I'm going to draw around my entire board, and we'll see what happens on the top now. I did change my rule to 50 mils. All right, I now have a copper pour with a 50 mil space. Notice how it kept away from my text, 50 mils away from everything. Much better. So let's do a file, save all, and we're going to talk about how to generate the files that we need to produce these boards. When we generate these files, they're called Gerber files, and they'll generate a file for every layer. To do that, if we go to our file up here, and we go to fabrication outputs, fabrication outputs gives me some options: Gerber files and NC drill files. Those are the two files we're going to need to generate. So let's go to Gerber files and select it. And it's going to ask units and inches, format 2x5. You want to pay attention and keep this the same because we're going to generate files twice. Once for our copper and once for our drills. So I'm going to leave it at inches and 2x5. I'm going to come to layers and say, which layers do I want to plot? Well, fortunately under plot layers here it says everything that I've used that's on my PCB, turn it on. Boom, turned them all on. I didn't have to do anything. I'm going to say OK. Altium chugs, generates a Gerber file. There's the Gerber plots for my top and bottom layer. Let's go back to our op-amp PCB, file, fabrication outputs, and then I want NC drill files. I'm going to click on it, and I'm going to make sure I'm not 2x3, I'm not 2x4, I'm 2x5 because that's what I chose before. I'm inches, not millimeters. I hit OK. It says import the drill data. Yes, please. There's all my holes. Everything's drilled. I'll go back to my PCB. I'll tell it file, save all. I'll save those CAM files. That's the computer aided manufacturing files there. And I have a nice PCB. I've generated my files. If I come to my projects now and I look here under my op-amp project, look, what do I have? Generated CAM files. Look at all those files. I've generated all I needed. This is the name of the project, op-amp GBL. That's Gerber bottom layer. Right? The GKO is Gerber keep out. The keep out is your board shape, right? Your board outline. GTL, Gerber top layer. Here's the one that's nonsensical. I don't know why they do this, but the op-amp.txt is actually the drills. That's your drill layer. So if you look at the folder where you saved your project, you'll see that there'll be one that says under your main folder, it'll now say project outputs for and the name of your project, and all these files will be there. So that's how to generate the files for our project. Thanks.